Hello and welcome to the Amateur Skeptics podcast special, I believe number 5. We're going to go with that, see what happens. With me tonight is Mac.
Hey everybody.
And Ian.
Evening.
And Kimberly.
Hello.
So we just finished recording our interview with Tara Ruttley. Tara? Doctor. Yes, doctor. Yes. And Mac was very diligent about always saying doctor.
Until the end.
Until I told her about the dick jokes, right?
No, actually, I kind of stuck my foot in it, but I was trying to be respectful.
No, and she was a lot of fun. We had a good time. I think she was
excellent. She was absolutely fantastic.
Very
charismatic.
My son and one of Brian's daughters got to ask questions of her.
Yeah, and of course they both, gravity was the big thing on our kids' minds.
Certainly.
So.
And we've discovered that mice can create their own artificial gravity.
So listen to the interview, and we hope you enjoy it.
Yes, and of course this will be in replace for our normal episode, and so we'll see you in 2 weeks.
This is Tara.
Hey, Tara, this is Brian Heinesser from the Amateur Skeptics podcast.
Yes, hi.
Hi, how are you?
I'm doing well. How are you speaking?
I'm doing good. I've also got Kimberly on the line, who I believe you've spoken with.
Yeah. Hello. How you doing? Good.
And I have our other 2 podcast members. I have Ian, and also I have Mac with us.
Mac. And your name, I'm sorry, did you say John?
Brian.
Brian. Okay, great.
Yeah. So thank you for joining us this evening. I guess so. You did a talk at the Botanic Gardens. That's where Kim saw you?
Right. Yeah, we were there as part of a big team effort of several of us from Johnson Space Center. NASA were up in Denver a few weeks ago promoting our exhibit called Destination Station. That's over at the Wings Over the Rockies set up there through the month of October, I believe. So several of us went out to try to do some outreach programs with the public. So anyone who cared to come and listen, we were there.
That's neat. So now I was looking over your bio. I mean, so your title is International Space Station Associate Program Scientist.
Correct.
That's a lot of words.
Yeah.
So what do you do?
Yeah, I laugh and I say, okay, it means nothing to anybody outside of NASA because it's a long title. So basically, we have an Office of Program Scientist for Space Station here at NASA. And so our office is responsible for coordinating the science that happens on Space Station with the principal investigators, coordinating with our international partners because they have research as well. Let's see, we communicate the scientific hotness that's going on in the research community to NASA headquarters and try to make sure we're on our game with regard to cutting edge. And then we also communicate the results and the happenings of what's happening on our laboratory up on orbit with the public. So I'm the Associate Program Scientist. Julie Robinson is the Chief Program Scientist, and I'm her deputy in the office. So we have a really good time within the office just working solely on space station research.
Beautiful.
That is pretty cool. Now, so you went to school here in Colorado. You got 2 degrees here in Colorado.
Yep.
A bachelor's of science in biology and a master's in science and mechanical engineering. And so, and that's what got you started and got you your job with NASA. Is that right?
No, it was obviously a big part of it, but I wanted to work for NASA since I was a little kid. So for as long as I can remember. So my love had actually already been in science more than engineering, and so I was headed down a path towards science. Knowing that one day I wanted to work for NASA. And so what happened was when I was an undergraduate at Colorado State University, I started participating with the AIAA chapter there, which is the American Institute of Aeronautics and Astronautics for students. And I was the only science major in that group. They were all engineers, and they were doing something with vehicles and rockets and launching. And I had a different interest, and my interest was in development of an exercise machine for use in space, for resistive exercise. Because the body muscles, it's kind of use or lose. And when you're in space, if you don't use your muscles, you start to lose them, just like you would here on Earth if you suddenly stopped exercising. So I went down that path, and that got me into the space community that I wanted to be involved in. But since it was the development of an exercise machine, I realized as I was going down my degree program in biology, and I was working this project in my senior year, I realized to make that concept come alive into reality, that it was real important to get a good understanding of the engineering, because I found myself wanting to create and create a prototype, and we ultimately ended up doing that as students and testing it on the Vomit Comet, which is the parabolic flight airplane at NASA. So in that whole endeavor as a student in biology, I realized an interdisciplinary approach is the smartest way, and it's actually a really fun way to get your ideas across from just conception to bring it to fruition. And while I was down at Johnson Space Center for one of these parabolic flights with my team for our exercise machine to test it in little microgravity parabolic arcs, there was a job fair, and I submitted my resume, and they just happened to be hiring, NASA just happened to be hiring for biomedical engineers in a new division they were starting up. So it was a little bit of, obviously it was very much preparation and very much timing, and as all those things came together, that's how I ended up in my first 8 years at Johnson Space Center as an engineer. And then in the last 2 years, I switched to science. I obtained my Ph.D. in Neuroscience down here at the University of Texas Medical Branch while I was working as an engineer at NASA. So I completed that in 2007 and have been in the office of Space Station Science ever since. So it's been really, really, really fun being here.
That's
Cool.
awesome.
Yeah,
Just
that is
following
awesome.
your dream like that and having it all line up. That's so cool.
Yeah, the coolest thing about it is it's just that it was all just fun. It was just doing fun things that you love, and it just kept coming.
So now, that project, was at the Continuous Force Resistance Exercise Unit?
Yes, as a constant force resistive exercise unit. Yep, and that one actually led us to a patent, and so pretty neat. We got to do a lot of fun things with that machine, and it was part of my master's thesis, and so yeah, pretty cool.
Yeah, Brian's been good this week. He did his homework for you.
I'm sorry, what was the question?
No, it wasn't a question, it was a statement. Brian, he actually did his homework on you, while the rest of us kind of were slackers this time.
Oh,
Dr. Ruttley, as I understand the constant resistant force, the unit you designed, essentially it's giving somebody something to work against that's not gravity, since gravity is not available.
right. And so when you're in space and there's microgravity, very, very little gravity, then you're right. You don't really use the muscles that you use here on Earth. You use regularly. You don't even think about. So in space, counter that muscle wasting, they had like an exercise device that could provide like a wasting routine. And since you're in microgravity, you don't get that gravity vector, so weights are useless. They just kind of float around. So you need something else to provide that resistance. And then the scientists, or the flight doctors, they wanted that in a constant force. So just like what you see in a weight stack machine here on the ground, which would be a constant force. And that's a challenge because most springs are not constant force. Most springs increase in resistance as you stretch them. And it's the same with rubber bands. So when we were students, we'd identified springs that are already on the market, and they're just called constant torque springs. And so as you pull on them, they maintain a nearly constant force, and then as they retract in on a nearly constant force speed. So you get constant force on the upstroke and the downstroke.
What's the durability of those constant force springs?
Yeah, the durability is, it varies, and the biggest challenge there is if you want a greater life cycle on a spring, the spring gets larger and larger. Right? You have to always give up something in favor of something else. So
Right.
it's a challenge between modularity and size and weight, which is what you want to aim for when you're thinking about space flight, lighter, smaller, more portable, versus the force output and the cycle life that you also need out of an exercise machine. So the springs vary on cycle life, depending on the size, and NASA has varied their requirements in terms of the next generation exercise machine that they'd like to see on the next vehicle, because they weren't sure what the next vehicle was going to be for a little while. So once the community gets their mindset back into place and thinking about what the next generation exercise machine would be for the next vehicle, then it'd be a lot more clear as to whether mine would even fall into the competition category anymore these days, or whether something new and improved has come along since then.
Sure. So I mean, I guess this leads us. I mean, there's definitely a lot of special requirements for medical equipment in space. Wouldn't that be the case?
Oh yeah, yes. So for my first 8 years, I was a flight hardware lead for the health maintenance system at NASA, and that is a system that consists of all the medical equipment for crew, and that includes the emergency medical equipment. And just like any kind of light hardware that you space station, they all have to go through rigorous certification before you even make it on orbit. So that's things like special materials selected for, they're non-flammable and for quality, persistent, and for off-gassing. You don't want materials that are going to off-gas horrible toxic fumes into the closed atmosphere of the space station. And we do things like vibration testing they have to provide. They can't be too noisy. They can't get too hot. So they're thermal. They got to be able to resist EMI and so electromagnetic interference and the launch environment, the landing impact environment. So there's all kinds of documents and paperwork and testing and integration tests and human factors tests that have to go into just getting just the basic piece of flight hardware space station so that we're very confident that it's a quality product and it's very safe for the crew on orbit. And so then, when you're talking health equipment, that's even more critical. And so with the health equipment, most of what's up there right now is commercial off-the-shelf modified. Certain things can't exist and can't be operated in the form that there are on Earth, same way that they are on space stations. And what I mean by that is, gravity-fed items, for example, IV bags on the ground. They're usually gravity-fed to the user, but in space, they'll use peristaltic pumps. And then there's a certain level of being paid to, the right types of pumps that don't create bubbles in the systems and can promote fluid flow. And even the pill bottles are designed so that when you open up a pill bottle, all the pills don't go flying out. And so there are lots of different modifications to currently existing hardware that is already used on the ground.
So I guess the most exciting exercise machine has got to be the combined operational load-bearing external resistance treadmill.
You're the Colbert. We came up with a good one for that one.
Yeah, that is quite an acronym. Yes.
We stretched that one. The second generation treadmill. All right, and it actually is quite popular, but we appreciated the support from Colbert because we can use the support anywhere we can get it.
Okay. What is the life expectancy of the International Space Station?
Yeah, very good question. So right now, we are mandated to extend the life of space station to 2020, and internally we're kind of looking forward to potentially 2028 as well. So while we are set for 2020, we always are looking ahead and preparing and thinking that far out to 2028. That's internal though, that's not really official.
Okay, are there plans on what will replace it?
Are there plans to replace it? Is that the question?
Yes. Yeah.
Okay. No, there isn't. I mean, so once it's done, I suppose, and we move on to the next thing. And it would be nice to be able to work two programs in parallel. At one point, we had 3 programs for a few years. We had Space Shuttle, Space Station, and Constellation. And now we're down to 1. This is an interesting thing, which is Space Station. And currently just kind of redesigning and refocusing the whole Constellation effort as to what comes next after Space Station. That's the big question. And so we're in a climate of change, as you've probably heard in the news and seen in the media.
Right.
But we know that space station is a pretty permanent thing, and actually space station will be used as that point to get us to whatever the next thing will be.
So, right now, of course, we're depending on the Russian space shuttle program, which recently, I guess that they've had some issues. Is that correct?
Yeah, it was a strange thing, in September they launched their Progress vehicle, which is an unmanned cargo vehicle that they've been launching forever and ever and ever, and especially the space station the last 10, 11 years, and they lost one. Yes, it left the launch pad and kind of blew up just about 5 minutes into launch. Pretty much lost everything that was on that vehicle, which for us wasn't critical. We had positioned ourselves pretty well with the final shuttle flight in terms of resupply and for research, so it wasn't too incredibly critical, but it did. It was a shock because that had never, ever happened before on a Progress vehicle. And, there was the unfortunate timing that, can't get past the fact that it just so happened on the first launch following the Space Shuttle retirement, right? So it's kind of like, could it get any worse timing-wise, So we were all raising our eyebrows and trying to figure out what that was about, and our Russian partners had, sprung into action right away, identified the problem in one of the boosters, and that booster is the motor within the second. I think it's the second stage booster. I hope I'm getting that right. I'm not a vehicle expert, but
yeah, that's
what
okay.
I understand, the second stage booster in a Progress, it shares the same booster motor in the Soyuz vehicle, which is the manned version of this what we use to send astronauts to the space station. So there's a lot of investigation going on within our agency and our Russian partner agency to make sure that we're comfortable with using the next Soyuz vehicle to get any of the astronauts at the space station. And those, I believe there's a series of pretty major meetings that happen, I believe, this week, and I'm on the status of that, and I quite honestly tell you, I don't know the status. You might be, if you're reading the news, you might be more up on it than I am. Internally, we're looking ahead to maintaining at least a 3-person crew. We are planning for worst case manning, but not expecting it at all. But of course, you always have to plan for the worst case so that you can be as flexible as possible. But our Russian partners, as far as I know, the last I heard, things were looking good. They'd identified the root cause. We're going down the path of fixing that problem before their next launch. They wanted to get 2 launches under their belt of that kind of a motor again before sending any of the astronauts back or cosmonauts back to space station on that vehicle.
What is the life expectancy of their shuttle program? I mean, are they looking to replace their shuttle, or are they just planning to use the Soyuz forever?
You know what? I can honestly say I've never heard anything about Soyuz retirement.
Okay.
So if there are those discussions, they haven't come across my desk.
Well, I haven't. I haven't heard them either. So.
Yeah. Okay. I was going to say yours is the first time anyone's ever asked me that.
Yeah. Well, it just occurred to me though. I mean, we end-of-lifed our shuttle program. So, I mean, maybe they would be thinking that maybe theirs is aging as well. So it just seems like if we're thinking about it, maybe they might be as well.
Quite possibly, although the difference between the 2 vehicles is the fact that the only reusable part on theirs is the capsule, right? And for us, it was most everything.
Yeah.
it was the boosters. Ours was a definitely more complicated machine, and the Russians, call theirs a good old standby, and so, but that's a good question. I don't know. I guess it's something for me to just personally look at, because I've never thought about it before.
Sure. No, I guess, so we have some commercial space entities that are looking that might be able to help us out. Would the Dragon SpaceX capsule be one of those options? Oh,
yeah. We have actually had both SpaceX and Orbital under in space act agreements with NASA since, I think, 2007 and 2008, respectively. And so they've been marching down the path for years and developing an unmanned cargo resupply vehicle for space station, and both of them are slated to demonstrate a docking to space station, I believe this December or at least early spring. I believe that at least SpaceX, I think both of them are targeted for December. So it'll be pretty busy. It'll be a pretty busy season, and we're looking forward to their demonstration of docking. And, I've been in the office for 2 years, and throughout that time that I've been here, I've seen them develop and I've seen them grow, and they're committed. And our office feels really confident in these startups. And they fronted a lot of their own funding. NASA fronted a lot of our funding to get this off the ground, and it's a really good test case. I think it's a really good indicator that the commercial entities could potentially pull off the future, which is the manned version of these vehicles. So I have confidence in the commercial sector of this.
All right.
So do you see that as where the future is then for space exploration?
Yeah, I think in the future it'll be an interesting thing. I don't know who will get the crew commercial contracts, but ideally there will be a few options for us and a few different companies, commercial companies, building manned vehicles. And it would be really a cool thing if NASA had the option to pick and choose kind of which vehicles we wanted to launch when, for which missions, and just to meet our different space station needs, our different exploration needs. So ideally, we'll have a lot to choose from. And then NASA is really also concurrently building, our Orion vehicle. And I think last month, NASA announced that there will be they announced the selection of their rocket that will go with that capsule. So now they're marching down the path and saying that NASA will have its own launch vehicle now for hopefully testing its first launch in the year 2015. So I think, we'll have this little short gap, and it's not the first time in history it's happened, but it's just that we're all here in recent history, and so we're all feeling it. But I'm feeling really good about, having options with all these vehicles come to development.
Dr. Ruttley, is there anything being explored other than rocket propulsion?
Oh, You mean for vehicle-wise, or?
Vehicle-wise, getting us to space, anything.
Well, I'm just stepping outside of my realm a little bit because I'm mostly involved in space station, but I have heard about the asteroid missions. I honestly need to get smart on those because I don't fully grasp what the goals are of these asteroid missions, although I do know that I understand that the orbital mechanics of just approaching and landing on one of these things is a challenge, and then potentially test different types of tools once you get to one. So I know that there's some kind of asteroid plans going on. Not quite sure beyond that myself, quite honestly. I know the plans for Space Station are to use Space Station as a test bed for analogs for Moon or Mars visits, running simulations, long duration phase types of different scenarios on Space Station, testing new types of technology for advancing beyond Space Station. That's about all that I know in terms of what's being explored. I'm sure there's tons out there,
Sure.
and I'm just not bright enough about all that.
No, that's okay. We're certainly asking questions that are outside of your field because, because you're from NASA, so we just expect you to answer everything. But we should get, but I guess I'd like to talk a little bit more about the science experiments that are happening on the space station, because you've talked in some of the interviews, you've gone into that a little bit more about what it takes to set up and produce one of these experiments in space. So what is going on the station space station as far as science experiments?
So Space Station right now, well, and the surprising fact that it is really at any one given time in any week, in any increment, and in any set period of time, you would have nearly 150 investigations running over a period of 6 months, which is pretty fascinating to me. And I didn't even realize those numbers until I came to work in the office. And I'm thinking, really, we're doing all that? I had no clue. And even to date, so the first 10 years of Space Station was really about vehicle assembly. And still we were getting a little bit of research done. Wasn't a lot of research. It'd be kind of like you being a scientist and you're trying to get your research done in a laboratory that you haven't even built yet, or being a doctor and you're trying to treat patients in a hospital you haven't even finished building yet. So the astronauts in the first 10 years, on orbit were just really, and rightly so, associated with and involved in the vehicle assembly component part of it. So now that the vehicle assembly is complete, we are smack in the middle of a change period. And this last year has been a huge change in just what's going on Space Station as we see things move from vehicle assembly to crew time being invested more in the actual research that's happening. So even in the first 10 years, when the research was definitely low in the number of hours per week and it was more of a focus on vehicle, you still got nearly somewhere around 1,400 investigations done over that 10-year period, and it represented around almost 1,000 scientists from around the world even, and resulted in nearly 300 scientific publications. And so even that portfolio over the first 10 years is only representative of about 20% of the capability of research that Space Station can handle before its 2020 time period. So it's a lot, and it's still not even potentially there. So we're looking forward to now that we have 6 crew. Well, the idea here is to have 6 crew members on orbit at any one given time. Right now there are only 3 as we're in transition between increments. But the 6-person crew, the vehicle assembly crew, has definitely very obviously been spending more of their hours performing research on orbit. And our office feels that because we get the results that come in, we get to see, hear from principal investigators, we get to see what's happening on orbit, and we get busy in coordinating all the science. And all the science that happens on Space Station. Space Station is a laboratory, like nothing you've seen on the ground, in that it's just so multidisciplinary. There's nowhere here on the Earth that you would find a laboratory facility that would have physical sciences, life sciences, human physiology research, and educational components, and all the bio and biotech technology and demonstration. All of those different laboratory capabilities in one huge facility. And then, even cooler than that, is the fact that now you have this gravity vector that's gone. So we've got all these different disciplines using it, and they're all going to create hypotheses around the fact that XYZ happens in the absence of gravity. Because gravity is what we've grown up learning about our whole life. So the human body develops and functions the way it does because of that gravity vector, and the physics that's so predictable and that we know are going to happen with motion and fluid flow. It's all based on the fact that we understand that gravity vector, 9.81 meters per second squared. And so we've never been able to take that variable away. And in science, when you're doing an experiment, you can take all the other variables and manipulate them and see what happens. But the one you can't really remove for a long period of time is gravity. And so you can theorize, and that's what we've done. But these days now with Space Station, you have a laboratory where you can think of pretty much anything you can think of that's affected by microgravity. You can test it out. You can test it out over a long period of time, months or years, versus just short number of days, or even if you're talking about parabolic flights or drop towers here on the Earth, you're looking at just 2 seconds worth of information. So with Space Station, you can take this gravity vector away, find out what happens differently. And not only that, but if you're a scientist, you like repeatability too. So when you're on the ground and you're in your laboratory as a scientist, you don't do one experiment one time. You do multiple different numbers of experiments that tell you something about your overall investigation, and get you different results that drive the next experiment so you get to your answers. And so the Space Station presence will give the scientists that capability, in that they can repeat their experiments over and over again and driven by different results with the experiment, modify a little bit, and give them time to tell a complete story of their overall investigation and come to an answer regarding their hypothesis. So it's a really neat, unique laboratory. Obviously, I can't say enough about it because I love it. It's pretty fascinating, and so many things that change when you take that gravity vector away.
No, I have I think this is a tweet, and it has your name attached to it. What happens in space stays in space unless it's peer-reviewed?
Oh, yes. I came from a tweet up. I was a speaker at a tweet up. Inevitably, someone always asks me the question about, how should we put it, mammal reproduction in space. And I said, you know what? I can tell you on the books right now, what happens in space stays in space unless it's peer-reviewed.
Okay.
So it hasn't been peer-reviewed. We know nothing about it.
Oh, that's interesting because I didn't quite understand what the quote was, referring to, and I hadn't associated it with mammal reproduction.
Yes. And,
it tells a whole different story.
Yeah, and then when I said it, it just went viral, I guess. People just picked up their phones and started tweeting that one. I'm like, geez. Oh, okay, I'll make a t-shirt too, because it's I get asked that question a lot.
I guess the next thing we'll get is people on the International Space Station with a sign saying, occupy orbit.
Yeah, exactly. Yeah, you never know, right? Goodness.
So we
Okay. I have a question.
Uh-huh.
Are we going to make it back to the moon?
Oh, you know what? I don't know.
I don't think anybody does.
I haven't read the news lately. No. Honestly, right? No pun intended. It's kind of up in the air right now. I'm sure who knows? Asteroids on our radar, so to speak. Gosh, I'm just filling all of these statements with puns. It's unintended, but I don't know. That's a good question. I could have told you what the answer would have been 2 or 3 years ago.
Ian, remember the rule. You were not allowed to ask her about the Autobot spaceship crashed on the moon.
Yes, I could tell you, but then,
That's right.
Yeah,
she's talking
with all the conspiracies. My guess is part of her job is to make sure we only know what we're allowed to know. We can't find out about the reptoids and the Area 51 and all that stuff. She's not allowed to talk about that, I'm sure.
That's right, sir. We're the government. We're here to help. So,
right.
It's for your own good that you only know what I'm telling you to know. And
there's an interesting question. Do you spend a lot of time, with people and their conspiracy theories? Like the aliens on the dark side of the moon and stuff like that?
Surprisingly, no. It actually depends on, maybe it might come up at an airplane ride if I'm sitting next to someone, or it depends on where I might go to an event to speak, and it depends on the crowd. But surprisingly, no. And I just probably get passers-by saying little things that I'm like, oh, interesting. And I found myself listening to a podcast, I want to say about a year or two ago. I don't even remember what it was or who it was. And I was fascinated by what they were claiming, that NASA never went to the moon. And I'm like, let me listen to what the arguments are for this again. And I was like, whoa, no, those are interesting. And, being on the inside, I don't have any top secret information, but sometimes the media or those out there give the government too much credit because sometimes we're just not that capable of being that elaborate. But I could be wrong. You just never know. I'm with you on that one. I probably know just as much as you.
Well, it's Jon Stewart that says that the government is incapable of keeping any secret. That eventually it's going to leak out. So
I don't think I want to know everything the government knows, though.
I
don't know. It's a catch-22.
Dr. Ruttley, I'm not sure if this is something you know that much about or not. I saw the health maintenance system and I thought, ooh, life support. And then I realized afterwards that my question was kind of off topic. But how self-sustaining is the International Space Station? How well does it recycle its, air, food, everything else? How much does it need to be resupplied?
Yeah, that's a really good question. I'll tell you what I know, and I know that it obviously recycles its own air. What I think I know is that it pulls from the air condensate or sweat. It recycles the urine into everything, and it pulls into to create drinking water from that.
Okay.
So that's a relatively new. The relatively new system is the urine conversion part of it. I believe that went up a year or two ago, and maybe even just a year ago. But they also supplement with water on the Progress flight. They definitely supplement food. There's no plants grown for food, for example. So all of their food is resupplied regularly with Progress flights or the unmanned vehicles. And the air, recycled. Water is tested for toxins. The air is tested regularly for the presence of toxins. Obviously small portable systems, not small portable systems, but powerless systems that are lightweight. There's a core in the water recycling system of Space Station, and it's got these things called microbial check valves that use a certain type of resin to clean the water and to add iodine to the water for health. And just the basis of that was created for Space Station was actually taken and made a spin-off, so to speak, by a company on the ground who's now started creating these little water recycling systems that can be deployed all over the globe in humanitarian relief zones where, the access to potable water is really not available, whether either due to earthquake or it's just the state of the community. And so it's a powerless system, it's gravity fed, where we've got these little resin beads inside of it that can clean the water and also provide iodine level, a certain iodine level of the water too. So as far as that goes, that's not the extent that I know, although I heard with the urine recycling system, there was actually extensive testing happening at Johnson Space Center for years leading up to that, and it did consist of volunteers offering up samples and processing those samples, and I understood it made it a long way and finally got certified to fly. So it was quite an interesting thing when it happened.
Can you talk a little bit more about the unmanned flights? I didn't really know that there were any going up, and how do they work, and how often are they going?
Sure. Yeah, so there are lots of different unmanned flights. So the Russians have these things called Progress vehicles, and their rockets and the insides are loaded with goods. And they go up, they deliver cargo. They go up about pretty frequent, 3 to 4 months or so, maybe even more frequent than that. I've lost track, frankly, because they come and go so quickly. They send things up, and then the crew can load trash back into it, and then it comes down and burns up on reentry. So it doesn't return anything, but it launches things up and then burns up the trash. And so that's Russian. And then the other unmanned vehicle would be the ATV, the Automatic Transfer Vehicle, and that's from ESA, the European Space Agency. They've flown only one of those, and I believe they're scheduled to fly their second one early next year, I think early 2012, I think in the spring. And they, too, can launch cargo up that can't return. So they burn up on reentry, trash and things that we don't need anymore. And then there's a third vehicle that is the HTV, and that's from JAXA, our Japanese space agency partner. And it too is an unmanned cargo vehicle. It can send goods up and return, and it can't return. It burns up on reentry. It too has only flown once, so its second flight will be in June. I think it just got moved to June 2012. So ATV and HTV definitely don't fly as frequently. Progress flies really regularly, and those are the three unmanned vehicles. Now, SpaceX and Orbital, when those vehicles come up and they do their demo flights in December, those are the NASA vehicles, and they too will be unmanned. SpaceX will have the capability to return things to Earth, which is good for our research samples. orbital will burn up on reentry. So at least we will have some return capability, which is important for things like blood and saliva and just plant samples and things that have shelf life that need to come home for analysis.
Well, because didn't on the last shuttle that went up carried a lot of seeds and stuff that are planned to be grown, and then they have to be grown to a certain point and then frozen, and they can't be returned right away. Is that true?
That's true. They can be frozen or they can fixated with certain types of fixatives. And basically what you're doing is you're just stopping their growth, because usually what the scientists are looking at here are gene expression patterns or root growth patterns that's okay if you stop the sample right there. They may not be necessarily looking for other things that you would associate with fresh plants, like the nutrients or off-gas byproducts or things like that. So yeah, you can freeze them or fix them.
Okay, sure.
Actually, if we can, my son would like to ask you a question.
Okay, good.
Okay.
Sure. Okay, just come right up there. Okay, go ahead.
Hi, is there any clues to artificial gravity?
Oh, any clues to artificial gravity?
Yes, that's what he asked. Yeah.
Okay, that's the question?
Yes.
Okay, so artificial gravity, what we actually do on space station is we can create artificial gravity, but not for humans. We can do it for plants by use of small centrifuges, similar to what you hear on the ground in a laboratory, not the big ones that you imagine when you think of people inside of a centrifuge that creates artificial gravity. But we can do that on the space station, because what we can do with that then is, for example, we might take plant seeds that are growing, want to see how they start to grow in microgravity. Then we might want to give them just a little bit of centrifugation and see how they grow in half a G. And then maybe we want to go to 3/4 G, maybe to 1 G, then take it all the way up to 2 G, and just look at the different gradients of gravity vectors and how that affects something like a plant. And there's, you can do that, mostly we do that with plants. There's been talks of doing that with mice, but we haven't done that, and we may not be doing that for a really long time because it's a lot more complicated with animals. And there's no plan to actually do that for humans on the space station. So we come up with other countermeasures to artificial gravity, and that's things like exercise that keeps our people safe. And you wouldn't want the whole laboratory to have artificial gravity, because then you would kind of ruin the experiments that we want to use, that we want to look for what happens when you take gravity away. It's a really tricky situation and a fine line to walk, but it was a really good question, too.
It's funny because Quinn's question, and I asked my daughter if she had a question, and her question was,
is there even a slight bit of gravity in space?
Yeah, sure. Yeah, there is. There's microgravity. So when you hear the term zero gravity, that's incorrect, and it's used a lot. But, as the space station's orbiting the Earth, it's still within gravity's pull. The Earth is spinning, and it's creating that gravitational pull. So anything inside that Earth orbit is actually still being pulled down to Earth. So the space station is free falling, and if you really were to take an accelerometer and measure that gravity vector, there is still some amount of gravity, and that's why it's called microgravity. 10 to the minus 6 is the micro part of it. And what you get is, the space station, if it keeps orbiting and orbiting and orbiting the Earth, you get a drag. Because there's still that gravity vector, the space station would eventually fall right back down to Earth if it didn't get a boost up occasionally from whether a visiting vehicle can give it a boost as it's attached, or it can actually boost itself up because it has propellant on board. So there is a certain level of gravity on orbit, and it's at the micro level.
So to get zero gravity, you've got to get much further away then.
Yes, you'd have to completely break out of the Earth's orbital
gravity well.
Gravity well. Yep.
All right. I just think it's interesting that both of our kids had gravity questions.
Cool question.
Yeah.
Too.
They spend too much time together, I think, is the problem.
Well, and even if you got out of if you got out of Earth orbit, wouldn't you still be in the sun's gravitational pull?
Yeah, I was gonna say, no matter where you are, I think you don't completely get away with it because there are these bodies all over. So I don't really know what the final that would be before that actually, theoretically, before that actually took place. Someone out there is smart enough to know, though. I bet I'm sure someone figured that one out.
Okay, thank you.
So you said you were thinking about doing artificial gravity experiments on mice, but you don't know if that's going to happen or not.
Right, because they're just a complex animal, and the machinery that would be required to support them, and the centrifuge that would be required to support them and still ensure that they're healthy, and you could measure all their variables like their heart rate and their body temperature and things like that to ensure their safety and well-being is a complicated matter. So if there
much more
were
complicated
critical,
than a plant.
Yes, exactly. Much more complicated than a plant. Now, if there were critical science value to it, it would definitely be investigated and looked into. And as of right now, there's just been no major scientific push as of yet. Not to say it won't happen, because we have certainly until 2020, and it potentially could go that way. As of right now, I don't think it's coming yet.
Can't the mice create their own artificial gravity with the little wheel anyway, though?
Yeah, you would think they could. they could, but then I imagine it would make some scientists cranky somewhere when they didn't stop, or when they didn't go when they wanted them to, or something like that. So those guys are hard to control.
I guess this is going way back, but I had heard the Nemo project mentioned.
Uh-huh.
That was one of your earlier projects, right?
Yes, I mean, it's so funny because someone came into my office today and said, "Oh, hey, you did Nemo, right? When was that?" And I was like, "Oh man, I can't even do the math on that. It was like 2004. Am I really? Oh gosh!" And she's like, "Oh, I'm so sorry. Did I make you too old?" I'm like, "Just go." Jeez, I feel like I just did that yesterday. But yeah, that was 2004, and I was Nemo 6, and now I think they're up to Nemo 14 this year. And so yeah, that was a really cool project. The whole basis behind it is to use a platform that already exists, and there's a habitat that's under the ocean. It's about 65 feet deep, and it's off the coast of Florida, and it's owned by NOAA. And marine biologists use it year-round, or at least seasonally to them, as they live underwater in this underwater habitat for days or weeks and investigate, and they go out and scuba dive all day and they investigate the coral reefs, and then they come back into this underwater habitat. They basically live underwater for days and weeks. And the thing is, at 5 feet deep, when you are scuba diving that deep, your body, your tissues become saturated with nitrogen. So to just come to the surface at any one given time would be a bad thing, because all those nitrogen bubbles, as you ascend to the surface, they would want to kind of escape out of your joints and your tissues, which could lead, yes, where you're going, to decompressive sickness.
Bends.
They call it the bends.
The bends, yeah.
The bends, exactly, the bends. And so what you become when you're down there for as long as they are, I think it's maybe 12-hour period, or less, actually, your tissues become saturated. So you're saturation diving, because they're saturated with nitrogen, and you can't come above 45 feet deep. So you have to say, if you go above 45 feet, you risk the bend. So NASA uses this platform about once a year. They have agreements with NOAA to fund a mission where 3 astronauts, or 2 astronauts and 2 scientists or engineers, 4 total, will go and perform a space analog mission for anywhere from 10 days to 2 weeks, and they really want to do a long one. I know, a longer term, but they kind of use it as a training and a learning experience, a simulation, to get a feel for what and how these people and hardware and science might perform in the closed environment, extreme environment of something similar to the space station. And so the unique thing about the Aquarius habitat, the name of the habitat underwater, is once you're saturated diving and you can't come above 45 feet, and it's a 24-hour decompression protocol to be able to come home. So it's just like space station. You can't just readily just say, "I've had enough," and just come to the surface, because that's detrimental. So NASA likes it because of that extreme environment portion of it. And when I went, my role was the engineer. I went with John Harrington, Doug Wheelock, and Nick Patrick, who were my 3 astronaut crew members. And we brought with us a suite of hardware experiments to test out. Just kind of getting a feel for how these things might work, getting astronaut input, getting real day-to-day use. Obviously, there's no microgravity present there, so we weren't testing function for microgravity, but mostly like human factors and usability and lots of different things. So we had, I think, about 10 different suite of pieces of hardware and experiments we were doing. And our mission was 10 days long, and we did a lot of team building activities. Obviously, the astronauts used it for something different than what I used it for. They used it for gaining leadership experience and fellowship experience, and just all these different training for them. And for me, what I got out of it was how to be a better engineer. because it was a way for me to get experience on end-to-end testing of a piece of hardware and that I, come up with conceptually, put together, and then actually took it to the astronauts in a simulated environment to see how these things would work and how the crew responded to them. And so our mission was 10 days, and boy, did I learn a lot about how to be a better engineer, how to be a better thinker, how to be a better designer, and anticipate my end users who were the astronauts a lot better than when I went in. And it was a really valuable thing for me, and it just changed the way that I approach procedure writing and human factors. And I think overall it made my leadership and my engineering skills, I think, a lot more sharper. So that was a really, really, really unique and super cool thing I got to do.
So how did your piece of equipment fare?
Oh, they did well. We had all kinds of different pieces of equipment. These days, I'd say maybe a few of those are maybe 1 to 2 out of 10 might be used on space station right now. But since then, technology has overcome and advanced. And so
Right.
some of the technology that we used back then was certainly bypassed, however many years ago that was. I'm afraid to do the math in my head. But I think they did great. We got really good feedback. And so I think it was pretty successful. Now these days when they do a NEMO mission, so that was the early days. Now these days they actually bring out big, like underwater robots, and they do these full, I think the last mission was something like a lunar mock-up scenario where they had like lots of big equipment and they were out there and working it hard and with lots of people. And so in my time it was a lot more, it was smaller, it was more confined. And the other missions early on were doing things like looking at blood, changes in the immune system under stressful environments, and changes in the bacterial growth in a closed environment. And so there was a little bit more science going on. I think these days there's still some science tagged onto it, like the psychological components and things in the blood draws, but they're a lot more focused on exploration as well.
Okay.
Well, can you talk a little bit more about who goes up to the space station, how long they're there, and again, I feel like a little ignorant. I keep thinking that unless we see a shuttle, launch, which are usually well televised, that nobody's going up into space. But you've talked about the unmanned ones going on a fairly regular basis, and these manned ones must be going up there as well to get people, bring them back down safely, and then bring the next crew up. Can you talk about the cycle of that a little?
Sure. So the crew, so at any one point there can be a maximum of 6 crew members on orbit. And at any one point the minimum would be about 3. And usually the way that works out is of the 6, oftentimes there are about 2 to 3 Russians, and the rest of the crew members can be a representative in any number, from NASA or the European Space Agency or the Japan Aerospace Exploration Agency, or Canada, the Canadian Space Agency. So it can be a mix of any number at any one period of time. Usually there will be at least one NASA and at least one Russia, and then everything in between. And so usually a crew member will stay for usually around 6 months. There's a little window by which they can stay longer before their health becomes concerned. In a critical situation, they could potentially stay a few months longer, but then NASA has these rules where they say, well, we're not sure what happens with the body here, so it's time to bring that person home. And so they do their rotations about every 6 months. So the Soyuz vehicle that sends our astronauts and our cosmonauts up and brings them home can fit 3 people at a time. So when 3 people go up on a Soyuz, that vehicle will usually stay parked for a number of months. And at any one time, there are, I believe, 2 Soyuz vehicles always dock at the space station as rescue vehicles too. So it's a rotational period where one will fly up, another crew will come home down in another one. So there will be between 2 and 3 docks, depending on if the new crew just got there and we're doing a swap out. So 3 will go up, and then 3 will come home, a different 3. And it's not exactly the same 3 that go up together that come home together. They may have different periods that overlap, and it all depends on the launch schedule. But for the most part, for a maximum of months, they'll stay.
Wow. And has anybody been up more than once?
Oh, yes. I believe there are 2 or 3 NASA astronauts that I can think of who have been up more than once on space station. One was Peggy Whitson, and she's a Ph.D. who was actually a female commander on space station. And she's now the chief of the astronaut office. She's been up twice, I believe. And then I believe Mike Fink, who's another astronaut who's been up twice. We're about to, I hope I'm not forgetting anyone, I'm sure I am, but we're about, Don Pettit is scheduled to launch soon, and this will be his second stay on space station as well.
Right. Okay. I can keep asking questions all night, so you guys jump in if you have more. But I wanted to ask, I've noticed you are really specific in calling it space station rather than the space station. Is there a language reason for that?
Yeah, I think it's just affectionate. It's hard to say.
Okay.
The space station to me is just so formal. And so internally, I think, you know what, no one's ever asked me that question, but internally I think the lingo is space station. As we talk about it, space station. Kind of probably just an affectionate name, I suppose.
Okay.
A good catch.
It almost sounds like English the way they talk about going to hospital rather than going to the hospital.
That's quite interesting, yeah.
I like it, though. I like it. Anybody else want to jump in? Did we broke down a whole bunch of questions. I think we hit a
I covered all the stuff.
I think we covered all my questions.
I asked mine.
Yeah.
Great.
So we did an article the other day about a fake ad about Domino's delivering to the moon and having a setup, and we read that Pizza Hut actually set up a pizza. Were you involved in that project at all? Or is that even true?
No, it
Kimberly,
probably is true.
Kimberly, she's involved in the astronaut's health.
Right, she wouldn't send a pizza to him.
The food labs would have been involved in the pizza part, but I'm not surprised. And in fact, we've sent up ice cream, and we sent up ice cream a couple of times, and every time the crew requests ice cream, we all get spun up because it's like tons more paperwork to have to process, and we have to move things around, and it gets all nutty and crazy, and the engineers go for over ice cream, and so I can't imagine what the pizza might have done, but we have protocol for ice cream. Pizza, not so sure.
Well, they had said that they couldn't send pepperoni up. They had used salami because the pepperoni didn't make it through the containment process.
You know what? I'm not surprised. I see what it does to the boxes it's delivered to at my house, so it's questionable for Space Station too.
That's an interesting question, though. What is? I mean, if something is going up to the space station, what is the process to send something like that up there?
To send a food item, or
food item. What would be the process?
Yeah. Normally the crew gets to decide they go into the food labs at Johnson Space Center, and they get to sample all the different foods available. And the foods will be either like dehydrated form or canned irradiated form, or like a powdery mix, soup or a drink. And they'll get to go and pick from a menu that they get to taste and try everything. And then that'll be packaged for their launch. And each crew gets a color code, and so each thing that they choose gets labeled with their color-coded dot. So it's kind of like when you write your name on your food item, you stick it in the freezer at work. Don't touch. This is mine. Tara's lunch. So they get their food assigned to them, and so they know what's theirs when they get on with it. And then occasionally, in some of the vehicles, they'll send fresh fruit as well. So I understand that fresh fruit is a treat that obviously isn't something they get pretty regularly if the vehicles are only visiting every 3 to 4 months. Right. But yeah, I remember hearing last year it was a big deal when they got oranges, and so I think anytime they get fresh fruit, it's exciting.
Has there been any, I was seeing a news article the other day about a woman down on the South Pole expedition who needed to get out quickly, and there was all this complication getting people out. Have there been any kind of medical emergencies that really affected crew and required to get somebody off of there quickly, or has anything like that happened?
To my knowledge, that has not happened. And I'm thinking back as far as I can think, and I'm trying to think, there have been instances of, close calls or certain anomalous things health-wise happening. Sure, there's skin rashes and there are viruses that are reactivated by being in space. And so there are health happenings that occur. I don't think there's been anything that has caused a crew member to have to come home early. And if they have, then they sure did a good job about integrating it nice and quietly, because I'm not aware of that, which is a good thing, I guess.
Yeah. And during the talk you did over at the Botanic Gardens, you talked a lot about how the space station is really owned by, obviously it's an international space station, but I found it really fascinating the talk you did about the congressional, I guess it was an act, am I right, that's to keep it open. Can you talk about that a little bit?
Yeah, so in 2005, Congress mandated, in the NASA Authorization Act, mandated U.S. assets of the space station as a formal national laboratory. And mostly, and national laboratories exist all over the U.S., and they're mostly associated with the Department of Energy, and they are basically a designation that are given to certain laboratories with fabulous capabilities that should be shared with America, with scientists, other government agencies, academia, commercial, to just get the most use out of those facilities. So in 2005, Congress actually designated the space station a U.S. national laboratory, which is a pretty bold move. And so what this means is there is a sector, an office that's been in NASA, and is now run by a nonprofit organization as of July. They're going to run that component of the National Laboratory for NASA. And what the National Lab Act means is that NASA can and has gone out and made agreements with commercial industry, academia, other universities, other government agencies like the National Institutes of Health and the National Science Foundation, the Department of Defense, USDA, agreements for them to use space station platforms for whatever it is their agency's purpose is for. So NASA's goal, actually, in the big picture for NASA right now, our mission is to advance space exploration. Our foremost mission is not to benefit the people of Earth, it's to advance space exploration. And a lot of people are surprised when they hear that, because we get so many benefits that obviously affect us on the Earth space. But right now, NASA's goal is advanced space exploration. But the National Lab initiative is to bring back benefits from space to Earth. So all of those who are participating in the National Lab effort are actually tasked to do so to bring benefits back to Earth. And another difference between NASA research and National Lab research is that NASA funds researchers, scientists, it gives them research money to advance NASA's mission for space exploration. But the National Lab component requires those participating entities to bring their own research funding to the table. So we'll let you use the space station and we will launch it for you and we'll integrate it all for you, but you have to fund your own research. And by the way, we'd like to leverage off of what you learn too, because whatever you learn to benefit Earth is definitely going to help us learn more about space exploration too. So any company or university or other government agencies that use National Labs sign space act agreements with NASA, and there are different levels of agreements as to what data can be shared and what can't. But because some companies like that proprietary edge. There's a commercial company right now called Genetics, and they have actually been sending different bacterial samples to space station in an effort to advance their vaccine development work. And NASA had found years ago, an early part of space station, that when you launch microbes to space, like bacteria and viruses, most of them, but not all, but most, become more aggressive and more virulent. And so just nasty. And so when NASA reported those results, we did so because we wanted to know what this meant for the crew on orbit, the health of the crew in this closed environment. And so we published those results, and this other company leveraged those results and thought, I wonder if we can use the space station microgravity environment to accelerate our research and development efforts for vaccine development. So what they've done since then is brought their own research funding to the table, signed space act agreements with NASA to launch their hardware into to the space station. And what they've found is they've launched salmonella, and one of the things that they've launched is salmonella, which is the bacteria that causes food poisoning, and it's awful, god awful. Right. And there's obviously no cure for that. When you've had it, you just gotta wait it out and pray for the best, you know. I wonder, why hasn't anyone solved this problem yet? But so Genetics has, based on salmonella, identified the genes that control that virulence and a couple of other factors that control the aggression of salmonella, and have been able to develop a vaccine against salmonella, and they're in the early FDA approval process right now as an investigational new drug. And anyone may know that once you start the FDA process, it could take years and years and years before you actually see anything, if you can even cross that so-called valley of death and take something to market. But they've at least had success initially with Salmonella, and they've since launched MRSA, which is the antibiotic-resistant staph that runs rampant in hospitals and afflicts mostly the elderly and the very, very young, can't themselves from that. And they've also, there's another commercial company, actually a company out of the University of Arizona that's looking at, the pneumonia bacteria, some of the bacteria that causes pneumonia. So it's kind of a neat thing because, these national lab companies who've got their own funding, they don't have to really tell us any specifics if we agree to that. Some of them may just tell us, leave us alone, it's proprietary, we'll tell you the very top level, but don't ask for more. And maybe that's what we sign up to. And then in the end, the Earth benefits obviously can come back. So there are all different levels of agreements and all different types of research and different drives for that kind of research within the national lab effort.
Yeah, the Salmonella one was interesting. I was reading about that earlier today as well. And
good deal.
Yeah. Well, we've definitely got an hour worth of recording here.
Yeah, this has been awesome.
Yeah, thank you. Yeah, this has been great. Thank you very much for joining us.
Yes.
Oh, you're very welcome.
Thank you for taking time out of your evening, Tara.
Hey, man, it's always fun to talk this stuff. I just, anytime anybody asks me to, I'm like, sure, what can I sign me up,
That's
the more
great.
people I can talk to about it, the better, because it's just great to know you guys are interested and you are out there spreading the word for it, too, because we are a small group in our office, so we count on you guys who care about this stuff, obviously, as much as we do, and I think your whole podcast, idea is great, and I think your topics are really fascinating, so you should keep up the good work, too.
Well, thank you. Our 4 listeners will really appreciate that.
Good!
I told her we had more than 4.
I'll be your 5th one.
That's great. Well, have you actually listened to our podcast?
I actually haven't listened to them yet,
Okay.
but I actually just looked at the topics and
Well,
things like that. So.
you should be honored. We toned down the dick jokes just for you.
You toned down the what?
The dick jokes.
Oh.
we
Classic,
buy.
Brian.
I know, exactly. Busted.
Much appreciated. I think we almost crossed that line with the what stays in space stays, what happens in space stays in space.
Yes.
You held it together really well.
Well, this will be one of our very few clean podcasts.
Yes.
Well, thanks for the warning if I go to listen.
Yeah.
Maybe I gotta back up and restate what I think about your podcast.
Yeah, exactly. You might want to. You might want to reconsider being associated with us in any way.
And he tells me at the end of his interview.
Well, of course, I'm not going to tell you at the beginning.
That's the smart way to go.
No, I mean, for the most part, we are very much, a very science-oriented enthusiast podcast, for sure.
Wonderful. Good. That part I'll take and walk away with that.
Yeah. All right. Was there any other questions?
I think we're good for tonight.
Okay.
That was a good interview.
Yeah.
All right.
It was very enjoyable.
All right, guys. You have a great evening, and contact me if you guys need anything else.
All right. Thank you.
Kimberly, for the
Thank you.
invite.
Oh, thank you for the presentation you did, and yeah, when you said that in the presentation that you love talking about it, I was like, oh, how cool would this be? So I'm really glad this got to work out.
Me too. Fantastic. Thank you, Kimberly. That's wonderful. I'll be happy to do it for anybody else too. So just let them know.
All right. We will.
Great.
All right, guys.
All right.
You have a great night. Thanks for the call.
All right.
Thank
Good
you.
night.
All right. Take care.
All right, guys.
That was fun.
Yeah.
All right.
Thank you for listening to the Amateur Skeptics podcast. For more information about the Amateur Skeptics, go to amateurskeptics.com. To send us feedback, suggestions, or big flaming insults, feel free to contact us at WTF@amateurskeptics.com. Other contact information can be found on our website.
Music for this podcast was provided by OMG. For more information about OMG, go to their website at myspace.com/OMGHQ. The Amateur Skeptics podcast is released under a Creative Commons, Share Alike, No Derivatives 3.0 license. We'd love to have you share our work with other people. Please do not edit or change the file.
Amateur Skeptics website, Facebook, and podcast album art is provided by and copyright Shadow Knight Digital Portraiture. Larger prints or custom pieces are available upon request.